Hey guys, today we're going to be talking about hyperbolas. It will be our third type of conic that we introduced on our first day. We already talked about circles, ellipses, and now we're going to be looking at what a hyperbola is. So I want you to think about the hyperbola is a shape. It's a curve that has two parts to it. They open away from each other, and it resembles like a parabola. Think about a parabola that has a twin that is a reflection of itself about some center point. This is called the center, where H and K is the center of our parabola. All right, and we also have foci, just like we did have in the ellipses, but I want you to kind of think about like opening up the ellipse. You can think about it that way as well. Now, one of the things that we also talked about in ellipses, if you compare these two formulas over here, what I want you to notice is the difference between the formulas when we have a horizontal, what we call transverse axis. You will have a binomial squared in which the binomial for x is on the left-hand side of this difference right here. And that is a huge difference between ellipses and hyperbolas. Is that symbol right in between your binomial squares? And in ellipse, recall, this was plus, all right, over here. But in a hyperbola, it is the difference, all right, and that also will help us to understand the definition of a hyperbola. It's a set of points whose differences of the distances from two fixed points of our foci is always constant, okay? All right, so main differences here is you have a subtraction sign instead of a plus, all right, and another difference over here is whatever binomial is listed first tells us which axis the hyperbola is going to be centered around, okay? So when the x binomial is in the first position, we call this a horizontal transverse in which the hyperbola is along the x-axis. Now notice in this one over here that you have a y minus k squared in the first position. That will give us a vertical transverse or major axis if you want to think about it that way. Now notice along the y-axis, we do have our hyperbola is elongated up and down. All right, and the A's and the B's, the A is always going to go with the first of the two terms here in your equation. So notice A has nothing to do with one being larger than the other. When we start relating A, B, and C together, we will see that A is always in this first spot. We're going to talk about that. Okay, so what is A? A is simply the distance from the center to the vertex. All right, so in both of my illustrations here, the vertex is kind of like, well, it's like the vertex of a parabola, but you have two of them. All right, so if you look at both of the vertical and the horizontal displacement or the horizontal orientation, you have your vertex, all right, and you have your center here. A is simply that distance between those two. So this is A, and we have another one if it's horizontally or vertically oriented. A is from here to here. Okay, so the distance from vertex to vertex, we would say is 2 times A. I'm just going to write it on one of them. Okay, all right, so the B value, on the other hand, is the distance from the center, and that's going to be this number right here. If you were to take the square root of the second denominator, that would give you from the center straight up the distance of what the value of B is. All right, so that's from here to here. All right, so that would be, it's not really a minor axis. We don't call it that, but we can kind of think about it like that. So there's your B and your B. And the distance from end to end, you would have 2B. All right, now what I want you to notice, and this is very important, if you were to go up B, down B, to the left A for the horizontal, to the right A, I want you to imagine you have a rectangle right there. And the beautiful part of that is what will always happen, and this is how we're going to end up graphing our hyperbolas, is that if you were to connect the corners of those rectangles, you would form this dotted line. This is called an asymptote. And simply the asymptotes, I want you to think about it as a line. All right, so from the center point, the equation of that line, we can think about if it's centered at 0, 0, the slope is up B, and over A, so rise to run. And here's that formula. It's a plus or minus, because think about it. We can go up to the right, there's the positive. We can go up to the left, and there's your negative. Now, as we progress, this one now is centered at 0, 0. If you were to take these lines, if you remember translations, it's just simply slide it to the left or slide it to the right and move it up or down. We're moving that center point, which means that you are translating it, the value of H and K. This is what we call a liar. It's always the opposite of what you think. And this is actually moving it up or down. So the equation of those diagonals are simply the A and the B value based upon, is it horizontal or vertical? If we were to look at the vertical transverse from this point, the rise is A and the run is B, so the formula changes. Don't get stuck on formulas. Just ask yourself, what's the slope? How much are you rising? How much are you running in that little box? And then everything else will fall into place. If you know what the center is, you simply put H and K into that formula, and now you have a standard form of a translated diagonal plus or minus 2 lines. So they're really easy to graph once you get the hang of it and you understand it. The last component that you would probably want to graph is your C value. Now the C value is simply the distance from the center all the way to the foci right here. So this is C, and you've got another one here. We're going to call that C. All right, so in an ellipse, if you remember, C squared was equal to A squared minus B squared. But notice the difference here. Now C squared is equal to A squared plus B squared. All right, so it's the opposite. So the signs kind of switch with each other in that formula. All right, so why don't we just dive into a couple of problems here. And remember, just like the ellipse, we always want a 1 right here. All right, so how do we get a 1? Whatever number you have to divide both sides by that, and then your A and your B will come to life a little bit. Okay, and then go back and read this over here. The size of A, or that A value is always going to be in the first denominator. Okay, all right, so let's do some of these. And first step would be to go ahead and put it into the proper format. So let's go ahead and do that. And we will start by taking these and, hold on 1 second. Okay. All right, give me 1 second, you guys. I'm gonna go ahead and get started. Divide both sides by 36, put it into the proper format. All right. Sorry, guys. My kids actually just walked in while I was recording this video, and I had to go and run and hide on them. Okay. Otherwise, that dog's going to be barking. And all right, here we go. Let's try this again. All right, so divide everything by 36. Simplify your fractions. Identify your major axis. All right, so I'm going to start by dividing by 36. Hopefully, you guys are way ahead of me. All right, so I'm going to divide by 36. Boop, boop, do. Hurry up, get caught up. And I get a 1 over here. And we're always going to simplify. All right, so let's simplify this 4 over 36. And on this side of the equation, 4 goes into 36. You get 9 times. And 9 goes into 36 4 times. Okay. And you get 1. All right, so the first thing that I like to do is I always identify the first position. So based upon this, this is telling me that this is going to be vertically orientated. You see this y squared's in the first spot? That tells me it's going to be doing this along the y-axis. All right, so the center, notice there is no 0 or there is no h and no k value. So right away, I know that this is centered at the origin. Okay, so the center is 0, 0. I can go ahead and get that center point. The next thing I want to do is identify my a squared. Now keep in mind, this is a squared, and this one over here is b squared. All right, so I'm going to make that little box. All right, so from the center, I'm going to take the square root of 9. My a value is square root of 9, which is 3. Let's do blue. And then the square root of 4 is 2, and that's my b value. And we will end up doing our c value too. Why don't we just do that right now? You know that c squared is equal to a squared plus b squared. C squared is equal to, those are already squared. You don't have to redo it, just 9 plus 4. And c is equal to the square root of 13. And I would put that in your calculator so you can graph it is 3.6. But over here, I will record it as a square root of 13 so I have an exact value. Okay, so from that position, I'm going to go up a. So a is 3. 1, 2, 1, 2, 3. Put a dot. And I will put little v for vertex. Go down 3. 1, 2, 3. And a v for vertex. All right, so we want to do that one first. So that is going to be the point of the, we can say, the points of the, if you want to think about it, two parabolas, but even though we call it a hyperbola. Okay. Square root of 13 is 3.6. I'll just put my little dots there. 1, 2, 3, a little bit past the halfway point. And we have our 1, 2, 3.6, and there's our f again. All right, so now we're going to go ahead and graph the b value, which is 2 to the right and 2 to the left from the center. And then you want to make that little rectangle. All right, so let's go ahead and make that little rectangle. It's going to go have the dimensions of 4 by 6. There you have it. And then the vertices, we can go ahead and identify those and label them. You are 0 plus or minus 3. And that's just your major ones there. You're not going to do anything on left to right on this one. Your foci, you have your 0, if you were to name it, 0 plus or minus square root of 13. And then your asymptotes, if you remember, all we're doing is we're naming, or we're going to be identifying what is the equation of the line that simply goes through those. So if you were to name that equation, it goes to the center, and the slope is rise 1, 2, 3, run 1, 2. If you went the other way, 1, 2, 3, 1, 2. So these are going to be important to graphing, and we absolutely want to graph those. All right, so we're going to go ahead and do that, and do those as dotted lines. Do not do those as solid, because what those become is there's asymptotes, meaning our lines will not ever, or hyperbolas will never ever cross these lines, but it will approach them. So that's what we call an asymptote. So I'm going to go ahead and extend that. It's going to go through the center. All right, and I'm going to do another one here. And those are the asymptotes. All right, so we're going to ask you for the equation, and we're going to also ask you to graph them. Now, they do go on forever. Forever, never, never. So we're going to put these little arrowheads there. And the equation is now h and k. Keep in mind, h and k are 0 and 0. All right, so it's just going to be plain old x there. So you end up with y equals plus or minus the slope is up 3 over 2. So 3 halves. And then x. Okay, so there you have that. So once you have those asymptotes in place, and once you have the vertices labeled, now it's super easy. Now what you're going to do is make a nice smooth curve. You're going to start on one side of the asymptote where the vertex is, and you're going to make this little curve. It's going to approach this line, but it's never going to cross it. Now that hyperbola goes on and on forever. And you're going to do that on both sides. Find the other vertex where the A value is, and we're going to simply follow that curve. They're actually kind of cool. All right, there you go. So let's do that again. I'm going to do it officially here, starting at the vertex. It's going to approach, and over here it's going to approach. Go back to this vertex. It's approaching, and then it's approaching. All right, so again, our plan of attack was first to identify which axis that it is lined up. Whatever is first, since y is on the left-hand side of the difference symbol, that means it's oriented vertically. You're going to find what the square root of that is, and from the center, you're going to go up in the orientation that you want it and down that amount from your center. Then you're going to go left and right, your b value, and then you're going to make that little box, and then from the center, you're going to go up and over and get your slope. And it's plus or minus because remember, we're going to go to the left because you have the negative downward slanting line. And then if there was a translation, an H and a K value, you would have to include that here and here. And then once you have that vertex identified there, you can just simply make the curve follow those dotted lines. Easy squeezy once you get your pattern. All right, so let's try another one. Oh, this one's even easier, other than there is a translation. All right, so now I want you to notice this one's orientation. This one's orientation, you have X written first, so that tells me that now this is going to be oriented this way. All right, so identify your center. Your center is always aligned. Now be really, really careful here. All right, so X, represents the 4 will represent your H value, because sometimes if these two are switched around and Y was first, you don't want to make a mistake of calling this H. This is always the K with the Y, and whatever number is next to X is always your H value. All right, so watch out. I think we're going to see that in the next problem. All right, so center. -4 is always the opposite, and a +2. All right, your A value is the square root of 36. Your B value is going to be the square root of 64. Square root of 36 is 6. Square root of 64, you get 8. And then we can go ahead and just, why not, get the foci value. C squared is equal to your A squared plus your B squared. I'll just write it out for now. Put the numbers in. 36 plus 64. And you get 100, and look at that, perfect square. C is equal to 10. All right, notice my graph is counting by 2s now. X is first, so it's going to be orientated this way. Start by plotting your shifted center. The center is going to go -2 or -4, +2, so I'm right here. So this is my center. And then I'm going to go 6 to the left and 6 to the right for my vertices. 1, 2, 3, 4, 5, 6. I got a point here, so there's one vertex. To the other side, 1, 2, 3, 4, 5, 6. Got another vertex here. Looks like my foci are going to be off the page, but that's okay. All right, and then now we are going to complete our box. All right, so the 8, we're going to go up from the center. 1, 2, 3, 4, 5, 6, 7, 8. We're right here. And then down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then now make that little box and make that box dotted. All right, we're going to make a dotted box. All right, so just follow the vertice. Go through the end point of your vertices and your B values. And now you have this box that we're about to draw the diagonals of. All right, so we can go ahead and do that. Again, keep it dotted. We're going to be drawing asymptotes. All right, so diagonally. So I'm going to take one corner and connect the other. I'm going to take this corner. It goes through the center. All right, so it's going to make that little crisscross. All right, I just shifted that one accidentally. Whoops. All right, sorry. All right, so now we're going to go ahead and do that. We can go ahead and graph our 10 if we wanted to. So this one was 8, so 2 more is that. And we got 10 about right here, right there. 2 more to the other side. So let's see if I did that right. Oh, nope, that wasn't right. So I got to count again, you guys. Sorry, I lost track. 1, 2, 3, 4, 5, 6, 7, 8. 2 more. 10's right here. So I'm a little bit further away, and the other one is off right there, right in my other work, which now that looks like a mess. And you got that there. All right, so now all you have to do is make your hyperbola by taking your vertices and just kind of make it curve up along, following that asymptote. Never crosses them. It never crosses them. Whoops, that one would cross for sure. All right, you can just kind of imagine it approaching, and it looks like a really wide parabola. Vertices, let's go ahead and name the vertices. If you just count, this one is 2, 2. You can look at the vertex and see it. So you have one at 2, 2. And the other one, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and +2, so -10, 2. And remember, the foci is the distance from the center to the F point. And we are, if you were to count right here, here's your center point. I will label that because sometimes it's a little bit easier to see. The center, I'll do this in purple. You're at negative 4, 2. And then simply you're going to start at negative 4. All right, now think about this logically. You are going to be moving in the x direction, but the y stays the same. So when I name my foci, again, the y stays the same. So I'm going to keep this as a 2 and this as a 2. And for the x value, if you start at negative 4, and we're going to go in this direction, 10, you are subtracting 10 from negative 4, which gives you a negative 14 for the first one, or you can just count dashes on your graph, however you want to do it. And then if we're starting at negative 4 and adding 10 to negative 4, we get 6, and then that would be that coordinate right there for F. All right, now your asymptotes, simply go to the center, and what is the equation of this line? We can, first of all, what is the slope? Simply rise to run will give you 2 points. So if you can use your B and your A value, just think about it logically. Don't use formulas. What is the slope? How far did you rise? How far did you run? So I went up 8 and I went over 6. All right, so up 8 over 6. Now, let's just kind of do that off to the side over here. All right, so the slope is up 8 and over 6, and we have a plus or minus, and that would simplify down to a plus or minus 4/3. And I did that on the far right of our page right here. All right, so now when we get our equation, we're going to put it in simplified form. So y equals plus or minus 4/3 x minus the h value minus of the center. Minus a minus 4 changes to a plus 4, and then k is as you see it. It's not a linear value. So the k value, this k value here is simply going to be the y coordinate, or you can look at it right here. Okay, your positive 2. Okay, and there you have that one. Let's try another one. All right, so in this next one over here, same thing. We're just going to try another problem, but I want you to notice in this one, now you have in the first position, you have your y value is first. So therefore, this is going to be up and down, and it's also going to be translated because now you have an h and a k value. Now, be extremely cautious here, you guys. This is h, which is next to the x. K is what is added or subtracted from your y value. Okay, so is the opposite. So your h, you look at what you're doing to x. All right, so it's going to be a plus 1, and your k value is a positive 2. All right, so the first denominator is a squared. The second denominator is b squared, and it is going to be vertically oriented. Let's plot our point at 1, 2. So there is the center, all right here. All right, and then we're going to get our a value. The square root of 9 is 3. So there's a. Your b value is the square root of 36. So you get 6. All right, so we are going to go up 3 and down 3. 1, 2, 3 from center. 1, blue. And down 3, 1, 2, 3 from center. So those are your vertices. And you want to make sure, again, that you note that you're going vertically here, all right, for your major axes. And that is going to be where the vertices of the hyperbola, or if you want to look at it as two parabolas, if you want to think about it that way, that's your points, okay? All right, so then now we need the other ends of our rectangle. From the center, you're going to go 6 to the right, 6 to the left. 1, 2, 3, 4, 5, 6. Puts us at that edge. 1, 2, 3, 4, 5, 6. Puts us over there. Go ahead and make your rectangle, which is going to simply be this little dotted box that's going to go through the vertices, through the ends of your B values. And now let's go ahead and draw those asymptotes from corner to corner and right through the center. All three of those will always be collinear. Otherwise, you made your box wrong or something went wrong. All right, so there you have that. Put your little arrowheads because it's going to travel forever and ever. And our parabola is going to follow that. We can do our parabola right now. We don't need the foci to do it. It's going to be super, super stretched out. I'll do that, and then that. And it's going to go right here. It never goes past those asymptotes. It never goes inside of the box. Our C value, we can go, if they ask for that, we can get it. And it looks like they're asking for it. So again, C squared is equal to A squared plus B squared. And you get 9 plus 36. C squared is equal to the square root of 45. Or C is equal to the square root of 45, which is 3 root 5 when simplifying it. And so we can graph it. This ended up on being roughly 6.7. All right, but I will write this as 3 root 5 right here. All right, and we can graph that. All right, so again, from that point, we are going to count up. It's from the center distance. It's distances. From that position straight up, we said 6.7. So I'm going to count up 6.7. 1, 2, 3, 4, 5, 6, 7. And they aren't actually, I didn't even ask for it there, but if you want to see a graph of it, you could. 1, 2, 3, 4, 5, 6, 7. It would be there roughly. Okay, but we're not too worried about the graph. They didn't ask it, but for fun, we're going to put it there. All right, but labeling our vertices, if you were to identify the coordinates, we're at 1, 1, 5. And the other one is at positive 1, negative 1. You can just look at the graph, or you can do the math by simply adding the distance of 3 to the center up and down, which only, keep in mind, affects your vertical, which is your y-coordinate. The foci, same thing. It is the distance from the center. Again, keep in mind over here that the x values do not change. You are only, when you're naming those points, you're only changing the y values. And so we're at 1, and the y value started at 2, but we're going to go up plus, so adding 3 root 5, but we're also going to subtract 3 root 5, and that'll get us to each one of those locations. All right, we'll make a prettier 5 there. There you go. All right, your asymptotes. Again, look at your slope. All right, so we'll do the little math on the side for the slope. All right, so if you were to go how far up and how far over to make that box. So what is the slope? It's rise to run from the center position, because that's 2 points on that line. Or you can go rise to run this way. All right, so we have a plus or minus. So we're going to go up 1, 2, 3 over 1, 2, 3, 4, 5, 6. And up 3 and over 6 is an easy squeezy 1/2. All right, so our equations are, where's my orange? Okay, so y is equal to plus or minus 1/2, and you have x minus the h value, so minus 1, plus the k, which is 2. So again, h and k are the coordinates of your center. And there you have it again. Right, we have one more to do together today. Go ahead and complete the square. Now we're going to do the same process of completing the square, just like we did when we did our ellipses. All right, and we're going to see which one ends up being in the front, which one is being subtracted from the other one. All right, so here we go. Go ahead and remember the process. The process is just like an ellipse when we are completing the square. We're going to put everything. Reshuffle. All right, so I'm gonna, for right now, I just kind of put the x's on one side, y's on the right, and then one's gonna end up on being negative. All right, and then we'll reshuffle again. All right, so you'll see how that'll all work out as you practice more of these in your homework. All right, so I'm gonna put the x's together, and it appears there's just a 9x squared and no linear terms. So we're just gonna do that. All right, and then we have minus, I'm going to put that in parentheses, minus 4y squared plus 8y. And don't forget, we're going to need a c value eventually. And then we're going to bring that 40 to the other side. So we have a positive 40. Okay. And then remember, when we are completing the square, you can't have this number in the front that is a 4. All right, it has to be a 1. So we're going to keep the 9x squared as it is. We're going to go ahead and factor out that negative 4 out of the front. So we're going to pull a 4 out and we get y squared. Now we remember we're going to want to be able to multiply back through and get a positive 8. So you're going to divide by a negative 4 by both of those terms, and that'll give you a negative 2y and then plus your c value. All right, so right now I did nothing other than reshuffling, distributing out that negative 4 or factoring it out. And then now we're going to go ahead and complete the square. All right, so now we can go ahead. Now just double check. If you multiply this through, you will get this back. All right, so we've done nothing but just writing it in different format. Take half of the negative 2 and square it. There's your c value. All right, so our c value over here ends up on being negative 1 squared is a positive 1. All right, but remember, we didn't add 1 to both sides. We actually added negative 4 times 1, which is a negative 4. Now we have to subtract to the other side. All right, so we do want to be consistent there. So minus 4. All right, go ahead and complete the square. We're going to move forward. We have 9x squared minus 4. Factoring that, you get y minus 2, or y minus 1, sorry, y minus 1, quantity squared, and then that will equal 36. Now we want a 1 on the right-hand side, so I'm going to divide this side by 36, this side by 36, and both terms by 36. And now this yields a 1 on the right. 9 divided by 36 is x squared over 4. I just simplify that fraction. And look at where the negative's at. The negative is, you have the x squared term first, and you have the y divided by 7, which tells me that the orientation, and I lost my 4. There it is. I knew I'd get it. 36 goes in for 9 times. All right, now we got it there. All right, so there is your standard form. Notice that the x is first. Therefore, this is oriented horizontally. X takes the hyperbola on the x-axis, so it's going to be doing something like that. All right, so let's identify what the center of our hyperbola is. There's no h value, so we say that that is whatever's subtracted from x is 0 here. So this becomes a 0 for the center and a positive 1 here. All right, and let's find everything else. Go ahead and do it. All right, you guys, so your a value is the square root of 4, which is 2. Your b value is the square root of 9, which is 3. And your c value we can find by taking c squared is equal to a squared plus b squared. And that's simply 4 plus 9, which is 13. So c equals the square root of 13. We'll write that over here. And if you want to put that in your calculator, it's roughly 3.6. Okay. All right, so we're going to take that value and we will we'll fine tune our vertices, foci, and asymptotes. If you want to get ahead of me, pause me, or whatever you want to do, and then check your work, however you want to do it. All right, 0, 1, ready? X is 0, Y is 1. There is the center. Take your A value. It's going to be along the X. Make sure you're going to go 2 to the left, 2 to the right from that point. I have a point here. There's my vertex. 1, 2 this way. There's my vertex. Okay, 1 right there. All right, and then my B value, I'm going to go up 3 from the center. 1, 2, 3. And then down 3. 1, 2, 3. Go ahead and make your rectangles. Make it dotted. And then once you have your rectangles in there, draw your asymptotes. Connect corner, center, and corner. And make sure it's going through the corners. And do the same thing with the other side. Corner, center, corner. And you have everything you need now to go ahead and graph it. You want to make sure it's solid. Here, switch over. All right, starting with the vertices, we're going to go ahead and follow those asymptotes. Follow those asymptotes. Go towards it and follow it. If you really want a precise point, you can just say, oh, when x is -4, what is the y value? Throw it in and get a precise point if you want. There's nothing that says you can't do that if you want to get a couple more points on there. All right, but I just do a real vague sketch. If you want to put that foci in there from the center, we're going to go 3.6 to the right. So 1, 2, 3.6 is roughly here. And then I'm going to go 1, 2, 3. Did I count wrong? Center. 1, 2, 3.6 is roughly there. All right. And it should be a mirror image to the other side. All right. So pretty cool, huh? All right. Let's now get our slopes. Now we're going to go ahead, rise to run from the center to the corner of the box as your slope. Rise 3, run 2, perfect. That makes it nice and neat. It's already simplified. So we have y is equal to plus or minus 3 over 2. X minus 0 is just x. And then plus your k value is 1. So that one was a nice and easy one. Now let's go ahead and name those vertices. One vertex is negative 2, 1. The other one is a positive 2, 1. So I'm going to kill 2 birds with 1 stone. Sorry, birdie. And I get plus or minus 2, 1. All right, the foci, we can do the same thing. We are just going to add square root of 13 to the 0 left and right. And you get plus or minus square root of 13. And your y value stayed the same. Okay, there you have it. We are now, I think I hopefully got everything we need. Looking good to me. All right, guys, go ahead, practice them on your own. And the next day, we're going to do a little extension. We're just going to reverse the process. You could probably figure it out on your own. Go and reverse it. All right, guys, have a good day.